Hello, I'm Fernando Ike. I'm a developer advocate at Zoop. Today, I would like to talk about a continuous deployment as something a little bit different than what you usually see around the internet, simply as an automation deployment or the next step to continuous delivery. Some organizations don't realize how the important deployment strategy is. They only recall it when there are some incident after deployment a new organization version in production. So for any organization that wants to innovate and learning fast, it's very important to have a deployment strategy. Just look at the state of the DevOps report. They mention a metric related directly to deployment. It's a failure rate. Sorry. Uh, Oh, let me introduce myself again, but tell you about my experience. How long time ago I was sysadmin when I had to manage services like send email, Apache, and Samba servers. I hope that you never had done that. Yeah, probably if you use the send mail and configure you by M4, you understand. It's a bore, but it has a charm. After that, I played different roles in the IT industry as a solution engineer, IT consultant, IT manager, and CTO. My last job were about the creating or improving IT teams, release our better software and increasing resilience. So most of the texts, podcast episodes, and presentations state that continuous integration, continuous delivery, and continuous deployment are sequential steps. This picture represents a common sense about that. What do you think? Do you agree with what this picture represents? If you do that, it's not really a problem. It's if your thoughts are different, please comment in the chat or social media and reach out to me, obviously. Yeah, I would like to know what the configure integration, continuous delivery, continuous deployment means to you and how your pipeline happens. So let's back to concept definition. What's the continuous integration? For the reference, I use a Martin Follow site definition. The continuous integration is a software development process where the member of a team integrates their work frequently. Usually, each person integrates at least daily, leading to multiple integrations per day. Each integration is verified by an automation build, including testing, to detect integration errors as quick as possible. How the continuous delivery? How could be defined? Oh, let me use the definition I found in the Jazz Humble site. He's a co-author of an awesome book with the David Filer called Continuous Delivery, Reliable Software Release through Build, Testing, Deployment Automation. Continuous delivery is the ability to get changes of all the types, including new features, configuration changes, bug fixing experiments, into production or in the hand of users safely, quickly, in a sustainable way. Just humble site explain a continuous delivery and in me it's a hitting spot. Continuous delivery is about put the release card in hands of the business, not in the hands of IT. Implementing continuous delivery means the making sure your software is always production ready throughout its entire life cycle. That any build could potentially be released to users at the touch of the button using a fully automated process in the matter of seconds or minutes. This is why continuous delivery for many people is seen as the DevOps heart. I agree with that. After review of continuous integration, continuous delivery concepts through the words of the prominent people in the IT industry, let's see what the continuous deployment is. Although continuous deployment was coined by Timothy Fizz, I prefer to use the Jazz Hum definition. He wrote a text called Continuous Delivery and Continuous versions versus continuous deployment. In the text, he said, continuous deployment is the practice of the release every good build to users. For example, a continuous delivery tool or service that does any integration for commit pull requests and or measure requests is good. Pass all the tests, unit tests, integration tests, any other test that is important for the company, it's ready to go to deploy and release. This picture represented my vision what the hierarchy of continuous integration, continuous deployment, and continuous deployment is. Continuous integration, continuous deployment is a part of the continuous delivery because delivery gives us a power for business to decide which features it really be enabled to users of customers. Almost everyone knows some deployment strategies like a blue-green kind of release, but there are many other strategies. Our strategies mentioned here consider to use a container orchestration as Kubernetes to explain most of them. Most of the deployment strategies are possible applying virtual machines or bare metal servers. They are a little bit more complex to implement, but completely doable. Let's see then. Recreating in place, it's a basic for and common for every organization, teams, or project when they start from zero. Nowadays, in the high performance teams, it's seems old fashioned. Unfortunately, low performance teams or organizations still use its main strategy to their deploys. On the internet, documentations will find a reference to recreate or in place. They are basically the same thing. The application version is changing in the same server, either virtual machines or on-premises servers. A script or configuration manager tool like Ansible, Chef, Terraform, etc. Stop application version 1, copy version 2, start version 2. I didn't mention details about the process, but you can figure out that more steps are necessary to update. So let's see pros and cons. Pros. The process seems simple when it's not involved update database as add update columns. On application version, it's just simple to operate because you don't need to handle multiple versions in production. Cons. Operation can be complex for rollbacks. Updated versions could be painful when changes in the databases or in the application architecture are necessary. Um, Applications unavailable during version transition, it means deploy after office hours like a night or Friday evening, it's a nightmare. These are reasons for the Uber legend of never deployment on Friday evenings. Because in the case of bugs and the failures, you will end up working as tomorrow, no tomorrow into Monday office open hours. Sorry, my spelling fault. Rolling deployments is called Rampant 2. Basically, a new version that will deploy and substitute the old version by number of instances per time or percentual. Here, rolling deployment example. Instances are update 2 per time. Version 2 is deployed into instances. Container orchestration checks if it's healthy. New instances you will receive a traffic in 2 instances of the version 1 are marked as hold for a time until they are finally deleted. The next step is the continuous version, the continue, sorry, let's see again. The next step is to continue version deploy. 2 new instances are created and follow the same steps shown in the last slide until reaching 100%. Let's see pros and cons for rolling deployment. Pros, zero downtime for users, it's good. Prevent to release if all instances need with the new version as are not healthy. For example, if you have 10 instances for an application, if you one of them is a healthy, container extraction will return to last healthy version. Um, Cons, other hand, it could be hard to new deploy of version that has failed previously when this strategy is configured to small bets per instance or percentile. Backwards compatibility for databases APIs is very important because this strategy keeps multiple versions running simultaneously. Oh, blue green. It's a simple concept duplicate environment with the new application version. Route traffic to new environment after the old environment is deleted. It's simple and cool. Here are example with quattro instances with the version 1. Updating this version is to create the same number of the instances to version 2. If a health check system and/or a manual test don't detect any issues, the load balancer route traffic to version 2. After that, all versions 1 of instances are deleted. Let's see pros and cons for blue-green. Pros, zero downtime for users. Oh, it's good. Instantaneous rollback if a detectable issue is found. You can segregate the environment to upgrade the hardware or type of VMs like M4 to M5 if you use AWS. Cons. Duplicate compute resource and cost. If your environment is an infrastructure as a service, in the bare metal scenario, it's required. Oh, sorry. Yes. My apologies. I've committed a mistake in the phrase. In the bare metal scenario, it's required half of the service in the idle. It's a little hard to explain to auditors or executives that your servers are not running an application that is just waiting to be used in the next deploy. I know I'm using extreme example, but you got it, right? Be careful with dependent services like databases. They need to prepare to support multiple application versions. I need to drink some water. I made a lot of mistakes in the last two slides. Okay, go ahead. Canary releasing inspired in the miners in the canary bird tail. They take they took a live canary in the coal mine to identify toxic gases. After time, of the times the alarm only sounded once the canary was already dead. Fortunately, this practice is no longer used. For the IT, canary release is a way of version to become available to be tested in production for the set real users before to deploy for all users. An example in the canary release load balance split the part of traffic to instant version 2 and keep others users in the version 1. If everything fine in the version 2 instance already to start, new instances are created and the load balancer route the traffic to them until reach 100% of the users. Simple one, right? Let's see pros and cons for Canary. Pros, zero downtime for users, testing for real users, multiple versions running simultaneously, and cons compared to deployment strategies we have already talked about it. Rollbacks is lower if any issue is found. Application independence needs to good monitor, aka observability, to identify as quick as possible any issue. just for record, it's a production environment with the real users, even though it's a little amount of them. To implement a whole budget, it's really important for to keep a good relationship among teams. A/B test, A/B testing. A/B testing is a very popular for marketing and product professionals. It's more common to use a segmenting users based, to business policies. One of the interests of marketing or product person. For example, company wants to know what is the best color for payment button, red or green. A rule is created for routing users with the cookie value read for version 2. Load balance parser value in route the users with the head value to version 2 and keep the rest of using the version 1 instances. This test identified that the red button didn't increase the revenue, so just disable a rule route to all traffic route to version 1 instances. If this test shows that red button increases revenue, it will be necessary to use a strategy as blue-green or whole deployment or canary release to deploy version 2 for all instances. Oh, sorry, my bad. A/B test is not really a deployment strategy, but it's a way to important for business to have a good feedback about a product and service and that it making mistakes. To us technologists, to know. Uh, the next slide. So shadow is a very similar to blue green. If you check a Flagger documentation, they call this strategy blue green with the traffic mirroring. Let's see how this works. Like a blue green, it's a creating identical environments to deploy version 2 in the traffic mirroring from version 1 to version 2. Thus, you can observe the behavior of the version 2 with the real user traffic. If something had not gone well, just drop a route to version 2. If everything is good, just disable version 1 route and delete version 1 instances. Oh, shadow pros and cons. Pros: reduce the risk of the production environment and can use in pre-production environment to test if the application new version is good to deploy in production. Testing a new version with the real user traffic is good to know if a new feature can impact to the performance or break something in the application. Cons: if the application has integration with the third-party APIs that change this data, such as customer financial history, maybe it's good to use a hoverfly as IPA simulator. Oh, circles. My first impression of the circles that was very interesting. Circles for me, it's a mix of the A/B testing in Canary. It's a possible to segment your traffic for tests like A/B test or split your traffic based on application versions. For example, a version for Europe, another for Asia, and another of the rest of the world. Here's an example: circles deployment. How to traffic to many versions in production. Version 2 and version 3 have a different new features. Load balancer route is a small part of real user traffic to version 1 and another part to version 3. The same may happen for the versions 4 and 5. Here's an interesting version. The version 2 and 3 have a bugs that were to detect earlier. These are low impact bugs, but they are consuming your budget and they need to be stopped in the order not to consume more. Version 4 is a A/B test. This will stop you. Version 5 is good and must deploy to the rest of the instances. Error budget and most of part sorry. Error budget must be a part of your continuous deployment process. It's important to know the limit of the experiments on production. If the organization don't consume error budget, it could be mean that company doesn't have experiments and doesn't innovate. Makes sense, right? So pros and cons for circles. Pros: zero downtime for users, real users for testing, capable of running multiple versions simultaneously, quickly rollback, multi-tenant to support different type of applications and environments. So this is the beginning of the end. Here's a summarizer to compare deployment strategies that I told before in other slides. You see how this good, how this bad, what's consuming a lot of time and cost. So, and finally, about best practices. Doesn't matter which continuous deployment strategy you need to use it to. Here are the best practices for all of them. Backward compatibility is very important. Continuous integration, continuous delivery, continuous deployment are very important for high performance organizations. One should always have a whole back plan if something bad happens in a deploy. Observability is a new buzzword, I know, but it's good to know if something is to be wrong in deployment or when running multiple versions of application in production. And this is references. Thank Google Cloud a container solution for writing amazing docs about deployment. Other references are here too. And thanks so much, CDCom, and you for watching this my uh, failure to spell correctly. But again, thank you